Namaste everyone. Today we are going to prove the mirror's formula using trigonometry. You can do the same by using similarity of triangles, but it would be more convenient to prove this formula using trigonometry. Before starting the proof, there's a small promotion, guys. If you are preparing for any JEE competitive exams like JEE and NEET, you can go into Telegram app and check out these channel, guys. These are very helpful for your JEE preparation. They have question banks, they have daily quizzes and many more things which enhances your score in JEE and NEET. So I will provide link in the description below. Okay, now without further ado, let's start the proof. So here basically I have considered a concave mirror here. Let's name it as M and N here. And from here to here, this is the center of curvature. And here behind the center of curvature, I am placing a point object. Okay, then the rays from this object will go here and come back and hit somewhere here. Well, at this place a point image, of course, it will be formed. So let's join this like this here to the point here. This will be theta and this will also be theta. Why? Because the rays from the center of curvature to any point on the surface of the concave mirror acts as a normal. So it divides the ray into similar angles. Okay. For the proof, we assume that the radius of curvature is much greater than the aperture of the mirror. Aperture, what is the aperture? Mn. Mn is the aperture of the mirror. Okay. This concave mirror is actually, we assume it as a straight line instead of curved like this, because it is taken from a small part of a big sphere. We have taken this concave mirror from a small part from a big sphere, so that is why the radius of curvature is so large as compared to the aperture. Okay, let's consider this point as O and we will draw a small lines like this. This is O dash. O is basically the pole, so O is basically the pole. So okay, why not instead of O we'll name it as P itself, right? It would be more convenient. P for pole, okay, and P for this point. So this is basically pole and this P dash. So this is very negligible distance. So we assume that M P dash is almost equal to M P. Okay, it's almost equal to M P. Now let's consider this angle as alpha, this angle as beta, this angle as gamma. Okay, this alpha, beta, gamma are very small angle. It is very small, nearly equal to 0. So as it is nearly equal to 0, sin alpha will be alpha. Similarly, as these angles are very small, tan alpha equals alpha, tan beta equals beta. Why like this? Because the angles are very small, so this holds true, this condition holds true. And tan gamma equals gamma. Same for sine also. But if we consider for cos, it will become 1, because as this theta is very small, it is approaching to 0. So so we assume that this theta is equal to tan theta, as it is very small, because tan 0 equals 0. So we can say that 0 equals tan 0. Similarly, tan alpha equals alpha, as alpha is very small angle, beta is also same like that, beta is very small angle, so tan beta is equal to beta, and same for gamma here, tan gamma is equal to gamma. So this in mind keeping this in mind, and another thing, what is that, radius of curvature is equal to twice the times of focal length. You should know this. Radius of curvature is equal to twice the times of focal length. We will start our proof now. So, consider this triangle. Which triangle? O, M and C. Consider this triangle O, M and C. So, what can you say about this triangle by looking at it? Can you say that alpha plus theta is equal to beta? Alpha plus theta, yeah, this angle theta is equal to beta. Can you say that? How can you say that? Because it's a property of a triangle that sum of two interior angle is equal to opposite exterior angle. See, this same triangle I have written here, this is alpha, this is theta. So alpha plus theta, this angle we have written as beta. So can we say that beta is equal to alpha plus theta? Because we have in our 9th standard triangles we have studied that sum of the two interior angles of a triangle is equal to the opposite exterior angle. Similarly for this triangle also, there is triangle CMI. Similarly for this triangle CMI, so I have written here CMI, okay, CMI, okay. I stands for image also. I is that we are name this part as I also, and here only the image is formed, okay. So at this angle, can we say that beta plus theta is equal to gamma? Why? Because same sum of the two interior angle of a triangle is equal to the opposite exterior angle. So we can clearly say that gamma is equal to theta plus beta. Can we say that? Yeah. So let's name this as equation number 1 and name this as equation number 2. Right? Okay, now see this diagram. This is radius of curvature, right? From here to here. Radius of curvature. Let's name it as R. This is object distance, right? From here to here. This is object distance. Let's name it as U. Right? That's what we have considered here, right? And this one is image distance from here to here. Let's name it as V. That only we have considered, right? Yeah. So from the first equation, can we write that theta is equal to beta minus alpha? Can we write that? Yes, of course. We will send this alpha this side. So theta is equal to beta minus alpha. So we'll substitute in this theta, the value of this theta here. So we will get that gamma is equal to, instead of theta, beta minus alpha. Beta minus alpha. So another beta is here. Right? So next step, gamma is equal to 2 beta minus alpha. So from here we can conclude that 2 beta is equal to gamma plus alpha. Can we say that? Yes. Sending this one this side. So 2 beta is equal to gamma plus alpha. So what we have assumed here, that the angles are very small and the aperture is very less, and radius of curvature is so much large as compared to the aperture. So obviously it means we have taken very small part of the whole big sphere, right? So instead of beta, can we write tan beta here? Yeah, we can write tan beta. So 2 tan beta instead of gamma, tan gamma, as angle is very small, is nearly equal to 0, so we are writing like this, tan gamma. Instead of alpha, we are writing tan alpha. What will you give the reason? We are writing like this because angle is very small. When angle is very small, it satisfies this condition according to the trigonometry. Okay, so let's continue. So what is tan beta here? See here, what is tan beta? This upon this, right? See tan beta. Tan beta is this upon this. That is mp upon r. mp upon r. Okay, we will write 2 times mp upon r. mp upon r. R is radius of curvature, right? Next, tan gamma. What is tan gamma? Tan gamma is this upon this, right? We will write mp upon what is this? V. This is what is this? Image distance plus, next is tan alpha. What is tan alpha? Here tan alpha is mp upon this u. U is, what is u? Object distance. So instead of tan alpha, I will write it as mp upon u. From here mp will be cancelled because we have taken in common this side and cancelled mp. So we get 2r is equal to 1 by v plus 1 by u. We know that r is equal to twice the focal length. So if we send this here downside, we will get focal length. Focal length is nothing but r by 2. That is radius of curvature upon 2. Half the radius of curvature is nothing but the focal length. So can we write this 2 like this? That is, can we write this 2 like this? 1 upon r. Yes, of course. Same thing now. This will go upside, right? So okay, yeah, we can write like this, right? So if you feel it very difficulty in write like this, so we'll okay, let's not write like this. If you are very confused writing like this, so we'll see another thing. We know that I'll write here. We know that r by 2 is equal to f, right? So 1 upon f is equal to 2 by r, right? Yeah. So instead of 2 by r, I will write here 1 upon f, because 2 by r is nothing but 1 upon f, as f is equal to r by 2. So 2 by r I am writing it as f, that is equal to 1 by v plus 1 by u. Here you have your equation, mirror equation or mirror formula derived. So let's recall what we have did here. Let's see once again. Here we are proving mirror formula using trigonometry. That is, we should prove 1 by f is equal to 1 by v plus 1 by u. F is the focal length, v is the image distance, u is the object distance, right? Focal length is half of the radius of curvature. Here we have considered a concave mirror. Here is the center of curvature. Behind this we have considered a point object. Rays comes like this, hit like this, and comes back here, forms the image, right? And we have joined the dotted lines like this to this point. As this line passing, as any ray passing through the center of curvature acts as normal, it divides these two into equal angles, that is theta and theta. Okay, we have considered m, p and n, this whole, and this is called principal axis. Okay, now as we are considering that radius of curvature is very large as compared to the aperture is this one, right? And as it is very small, the angles are very small as the aperture is very small. So we have so it holds true that tan alpha equals alpha. Why like that? Because tan 0 is equal to 0 na. So it holds true that for very small angles this function holds true like this, that is tan alpha equals alpha, tan beta is equal to beta, tan gamma is equal to gamma. Why like this? Because alpha, beta, gamma are very small angles. So alpha plus theta is equal to beta because sum of two interior angle is equal to the opposite exterior angle. 9th standard triangle lesson, right? Sum of the two interior angle is equal to opposite exterior angle. So and same in this triangle also, sum of the two interior angle is equal to opposite exterior angle. So in we have considered theta is equal to beta minus alpha. We substituted in this equation. We got gamma is equal to 2 beta minus alpha. So 2 beta is equal to gamma plus alpha. So instead of beta I am written tan beta. We have considered here because because alpha, beta, gamma are very small. Instead of beta I am written tan beta. Same here, tan alpha and tan gamma. So instead of tan beta I am writing mp by r. Why? This is perpendicular by base. mp by r is the radius of curvature. See here, right? Tan beta, this angle, it is making this angle here, so we have written like this. Same for tan gamma, this one upon this. Okay, mp upon v. Next, same for tan alpha is this one upon whole this, that is mp upon object distance. So we have written here like this, mp and mp got cancelled. We got 2 by r is equal to 1 by v plus 1 by u. So we know that r by 2 is focal length na. If invert it, this will also be inverted. So 1 by f is equal to 2 by r. Nothing, yeah. Send this f here 1 will be there. You send 2 here, send r again down here. So 1 by f is equal to 2 by r. So instead of 2 by r we have written 1 by f, that is equal to 1 by v plus 1 by u. Here in an easy method you have derived the mirror's formula. Thank you.